Good morning, ladies and gentlemen. It is a great pleasure to have the opportunity to present my work entitled Design and Implementation of an Intranet Computer Network in School using Mikrotik. In this presentation, I will share the background, objectives, methodology, and result of developing an intranet network design to enhance the efficiency of digital learning in a school environment. This project focuses on using Mikrotik device as the main network management solution, aiming to provide stable connectivity, optimize bandwidth allocation, and secure access for both teachers and students. For the first, I would like to move to introduction. As we know that the development of information and communication technology has had a great impact of the world of education, encouraging the use of computer and gadget to facilitate access to learning. One form of utilization is the implementation of Internet networks in school. Intranet is a small-scale computer network within an organization that allows internal communication and collaborating using Internet protocols. And Emma Al-Rahman, as an educational institution committed to improving the quality of learning, still face obstacles in network infrastructure that has not been integrated. Currently, networks are only available in computer labs and rely on ISP modems, so they don't cover the entire classroom. This hinders access to online learning media, CBT application, and collaboration between students and teachers. The purpose of this research is design and implement an intranet network that cover all school areas and improve the network stability through bandwidth management. Mikrotik Router OS is a Linux kernel-based operating system that is specifically intended for Mikrotik routers device, but can also be installed on PC device and turned into a router or server. With Mikrotik, we can manage everything in network development, for example, such as construction of hotspot, bandwidth management, or user management. And as we know that QoS, or quality of service, is a mechanism in computer network that is used to regulate and guarantee the quality of service in data transmission. QoS aims to ensure that a particular application or service gets appropriate priority and network resource, especially for applications that require stability, such as video streaming, VoIP or voice over IP, and online gaming. And in this research, use the research and development method with the NDLC, or Network Development Lifecycle development model, which include the stage of analysis, design, simulation, implementation, monitoring, and management. The implementation used a combination of wire and wireless media, as well as Mikrotik device as bandwidth management controllers. For method, in this research applies the research and development, or R&D method, which aim to develop and implement an internet network system in the school environment. R&D methods are used to produce valid and effective product through a systematic research process as well as repeated testing. In the context of computer network development, this approach includes several stages, namely for the first is identification of user, for the second is design and development of network solution and testing the effectiveness of network, and fourth is system improvement based on evaluation result. As a development framework, the network development lifecycle is used, which includes the stage of initiation, planning, analyze, design, implementation, and maintenance. This model ensures that the network build can meet the functional needs of user, has operational reliability, and support optimal network performance. The analysis stage is carried out at the beginning, focus on identifying the needs of network system, the problem faced, and the selection of appropriate topologies. The analysis is carried out through direct observation of the condition of the infrastructure and interviews with related parties to obtain comprehensive picture of user needs. The second stage is to design the system to be used. Based on the result of the analysis, a network design was carried out, which included the preparation of topology, bandwidth allocation scheme, and user access planning. This design is visualized using GNS3 software to provide a preliminary representation of the network structure to be implemented. The design that has been created is then simulated using GNS3 to test the functionality and validity of the network design. This simulation replicates real field conditions to identify potential problems before the implementation process is carried out. After the simulation stage is carried out, it continues to implementation stage. At this stage, the network design is implemented directly in the field. Key activities include network hardware installation, IP address configuration, firewall settings, and implementation of QoS for bandwidth management. For standard value of each parameter, use the standard value set by TPON or telecommunications and Internet protocol harmonization over network. TPON is a QoS parameter assessment standard issued by the standard body ETSI or European Telecommunication Standard Institute. Here are the QoS standard value based on the TPON. For the first parameter is throughput parameter. And the standard for throughput in the table. And also the second parameter is latency. And the third parameter is jitter, and the last is packet loss. After implementation, network performance is monitored using the monitoring feature available on Mikrotik device. This monitoring aims to ensure that data traffic runs optimally and stably as needed. And the final stage includes regular maintenance and management of the network. Network management responsibilities are transferred to the schools as the owner of the infrastructure, including in terms of operational policies and system and improvement. This is the picture from Wireshark capture. And this picture, results show a substantial increase in packet volume and data flow. A total of 49,000 packets were captured over a span of approximately 103 seconds. The average throughput improved to 2.61 Mbps compared to only 150 kbps prior to implementation. Although packet loss increased slightly to 0.9%, this was attributed to the higher volume of concurrent traffic, reflecting increased network utilization rather than degradation in performance. Latency and jitter value also demonstrated remarkable improvement. The average delay was reduced from 24.5 milliseconds to 2.11 milliseconds, and jitter dropped from 35.9 milliseconds to 2.99 milliseconds. This improvement indicates more stable and responsive network behavior, especially under condition of moderate to high traffic. When benchmarked against the TPON QoS standard, the post-implementation metric all achieved index 4, the highest category across 4 key parameters: latency, jitter, packet loss, and throughput. This confirmed the network compliance with international standard for telecommunication quality and its suitability for digital learning environment. And this is the floor plan after implementation. As we see in this picture, there are 3 new access points, and all of this can coverage every area in the school. And the blue one is the connection using wired cable. Conclusion: the intranet network at MA Al Rahman was successfully designed and implemented using the NDLC model, combining wired and wireless topologies. Deployment utilized Mikrotik RB450GX4, RUIGI RG-RAP2200F access point, and PCQ-based bandwidth management. Post-implementation tests show significant improvement through reach 2.61 Mbps, latency 2.11 millisecond, jitter 2.99 millisecond, and packet loss 0.9%. All meeting TPON Index 4 standard. Expert validation confirmed the system as technically feasible and effective in supporting digital education and administration. For recommendation, further development is recommended by adding access point in signal weak area, transitioning to full start topology for better wireless QoS, performing regular maintenance, and considering integration with cloud storage, VPN, or AI-based monitoring to enhance features, scalability, and intelligence. That's all from me. Thank you for your attention and forgive me if there is some mistakes. And see you in the next meeting. Good morning.